Hello, my dear students. Today we are going to discuss another numerical problem related to the clutch. This is the simple numerical problem related to the clutch. Here you can see that this problem is related to the multi-plate clutch. So a multi-disc clutch has 3 discs on the driving shaft and 2 discs on the driven shaft. That it means N1 is equals to 3 and N2 is equals to 2. The outside diameter of the contact surfaces is 240 mm and inside diameter 120 mm. That means d1 that is equals to 240 and d2 is equals to 120 mm. Assuming uniform wear and coefficient of friction as 0.3, mu is equals to 0.3. Find, or we have to determine the maximum axial intensity of pressure P max that between the disk for transmitting 25 kilowatt. P is equal, capital P is equals to 25 kilowatt or 25 and 20 power 3 watt at 1575 rpm. Speed capital N that is equals to 1575 rpm. This is the, so we will numerical problem. So we will start from the writing given data systematically. This is the given data. All the data is written here and we have to determine the value of P max. P is equal P max that is equals to, we have to calculate. So we will start solving the numerical problem from power. So we know that power transmitted by the clutch P is equals to 2 pi nt upon 60. This is the simple equation. We have already used this equation many times. So from this equation we have to calculate the value of torque transmitted by the clutch, because we have the value of power and speed. So we will have the value of torque transmitted by the clutch. But we know that the torque transmitted by the clutch for multi-plate clutch T is equals to N mu W R. So n that is equals to, in this equation we have already calculated the torque, so we have to substitute the value of torque transmitted by the clutch here, and n is equals to 4. This is the 4. It is already given in the given data, and mu is equals to 0.3. 0.3 here you can see. And now we have to calculate the value of axial load W. The W is equals to 2 pi c r1 minus r2. We have already derived this equation, 2 pi c r1 minus r2. In this equation we have the value of r1 and r2, but we do not have the value of c. C is the constant, so we have to calculate the value of c so that we can easily calculate the axial load. So c for the in the question, the uniform wear theory is given. So according to the uniform wear theory, P max into R2 equals to C. See, that is it. This is constant. So P max is already, we have to calculate the value of P max, and R2 is given. So we have to substitute this value of C in this equation. This one is for axial load, that is W. So we have the value of W in terms of P max. All the we will have all the values, only unknown is P max. So W equals to something of P max. So now the value of W we have to substitute here. So that means this value of W in terms of P max. So here the value of P max. So but now we have to calculate the mean radius R. For according to the uniform wear theory, mean radius R, that is equals to R1 plus R2 divided by 2. So we will have the R1 and R2 both are given. So we will have the value of R. The only unknown is P max in this equation. So we will have the value of all the we have to substitute all the values in this equation, torque transmitted by the clutch. Then we will have the value of P max. So value of the P max, that is equals to 0.062 Newton per mm square. So this is the simple numerical problem related to the multi-plate clutch. So thank you.